Friction, it is helping us in every step. Still, sometimes we curse. Let us review this action in detail and try to learn more about friction. For clarity, let us replace the box with a simple cube. The self-weight of the box is acting downwards. An equal and opposite reaction is offered by the floor and equilibrium is established. The man is applying horizontal force on the block. Let us replace the man with a horizontal force. The system was in equilibrium for this condition. This indicates the presence of an equal and opposite horizontal reaction acting on the body. Being the only contact location with external bodies, the horizontal reaction must be developing at the bottom surface of the box. Let us call this horizontal reaction as friction. For clarity, let us remove the floor after maintaining vertical and horizontal reactions developed. We know that system was in equilibrium for this condition. Zero net force in the vertical and horizontal directions is supporting this. But it can be seen that in contrast to vertical forces, the line of action of the horizontal forces are at a specific distance and the same must be causing a rotational effect in the clockwise direction. Still, the system is in equilibrium. Are we missing something here? Yes, the assumption of equal and opposite reaction in the same vertical line is true for pure vertical loading conditions only. In fact, the support reaction will not be a single concentrated load acting in line with the self-weight. It will be distributed over the bottom surface such that magnitude and line of action of the resultant will be matching with the self-weight. Application of horizontal load will result in redistribution of the support reactions such that resultant of the same will be forming a couple with the self-weight. Magnitude of the moment generated will be same as the moment generated by the horizontal load couple. However, the direction will be opposite and system will be in equilibrium. Let us come back to friction as we have slightly deviated from the subject. Earlier, we have seen that the box continued to be in equilibrium even with gradual increase in the applied horizontal load. What does it mean? The horizontal reaction gradually increases as per the applied load. So, friction has an inherent property to adjust as per the applied loads. But we have seen that it has got an upper limit. At some point of time, the block starts moving along the direction of the applied load. A closer look reveals that after struggling for a while, the man is pushing the box with relative ease. This indicates that as soon as the motion is initiated, there is a drop in the frictional resistance developed. Let us see the entire process once again. Frictional force increases as per the applied horizontal load. This process continues until frictional resistance reaches the upper limit called limiting static friction. As explained earlier, the line of action of the normal reaction will be moved away from the self-weight such that summation of moments within the system is zero. Further increase in applied force initiates the motion and frictional resistance reduces to dynamic friction. The net force is causing motion of the box. Using this information, let us plot the variation of frictional reaction as per the applied loads. Frictional reaction will be same as the applied load until limiting static friction. Any further increase in the applied force initiate motion and a sudden drop in the frictional resistance is observed. This reduced frictional resistance is called dynamic friction and remains unchanged with further variations in the applied load. For static condition, frictional value will be same as the applied force and varies from 0 to limiting static friction. A constant value of dynamic friction will be maintained once motion is established. Now, let us look into factors influencing friction. We have seen that the man succeeded in pushing the box. Let us put one more box on top of it. With the same amount of applied loads, the boxes continue to be in the state of rest. Again, the higher applied load results in motion of the blocks. Once motion is initiated, the man is able to maintain the same with relative ease. Let us review one more scenario with the second box kept in front of the first one. It can be seen that the effort required to push the blocks is similar to second box kept on top of the first one. What are the inferences? Frictional force is directly proportional to the vertical loads, or precisely it is directly proportional to normal reactions. Experimental results demonstrate that value of friction is independent of area of contact. Additionally, the frictional force is dependent on some properties of surfaces in contact. This is defined by the coefficient of friction, mu. It can be seen that adding some lubricants underneath and ahead of the boxes will make it much easier to push. Frictional force can be expressed as F is equal to mu times N. Now consider a box resting on a horizontal floor. One end of the floor is pinned and let us gradually raise the other end. Oops, let us keep it at the limiting angle. The limiting angle until which an object sweeps on an inclined plane is called angle of repose phi. The self-weight of the box will be acting vertically down. This can be resolved into components perpendicular and parallel to the inclined plane. The perpendicular component will be W cos phi and parallel component will be W sin phi. At this limiting angle, the frictional resistance developed at the contact location will be the limiting static friction, and the same will be matching with the parallel component W sin phi. Similarly, normal reaction developed at the bottom will be matching with the perpendicular component W cos phi. The force coupled parallel to the inclined plane result in redistribution of the normal reaction such that the resultant is forming a counteracting couple and the net moment will be zero. Now, dividing the equations of force equilibrium, F by N is tan phi. We have seen earlier that for the limiting static friction condition, F divided by N is coefficient of friction. With that, mu will be equal to tan phi. So, the angle at which the sliding initiates is an indication of coefficient of friction between the surfaces in contact. The higher the angle, the higher will be the coefficient of friction. We have seen heaps of grains forming specific slopes. Depending on the friction between the surfaces, the angle will be different. The grains on the surfaces of the limiting slope will be in the verge of slipping. Any further material added will result in slipping and the same slope will be maintained. The science behind ant lion's method of catching prey is no different. The fine sand particles on the outer edge of the cone will be in the verge of slipping, and any insect happen to enter the area will be pulled inside along with the slipping sand. Now, we have seen that with a slope beyond an angle of repose, an object on an inclined plane starts sliding. Are there any other possibilities? Let us discuss the same in the next video.